All right, I created this video to show you not so much with the drawings, well, not at all with the drawings, really. I checked it with the drawings, but I'm going to explain how to calculate. First, I'm going to tell you that the difference in sag for running a 100-foot tape is 1/8 of an inch, pulling at 15 to 20 pounds, right? 15 pounds is right about a comfortable amount of pressure to pull with one hand and hold it for a minute, right? 20 pounds without any, at 20 pounds for a minute is a little much. You start to struggle. So I tested it 15 pounds on a tape measure with nothing, not the, just holding the tape by itself. If you're on the measuring end, is about 15 pounds. And it's pretty consistent. And the difference between 15 and 20 pounds is about 1/16 of an inch at 100 feet. So there's the pull tension is at 15 pounds. So here's the formula right here. I'm going to zoom in so you can see that. It disappeared, right? There you go. Right here, the correction is equal to the weight squared, and that's the weight of the tape, not the total weight, but the tape weight of the tape per foot, squared times the length, which is the measured length, divided by 24, which is a constant, times P, which is pull, squared. So we need to put that in a formula. So what we need is, we need the dimensions of the tape, and it's a 3-inch. The one that I'm using was the FATMAX. 3/8 is 0.05 to 06, 0.006. So, and I think that's pretty good. So here's the tape information that you have to input. So it's 3/8 tape. 0.006 was what I used with my caliper, with my micrometer. And the length of the tape is 100 foot. And I went through some math here to get the pounds per square, pounds per, let's just go through it. So I got cubic inches, right? That's my cubic inches. And then divide that by 12 cubed and you get cubic feet. And then multiply that times 492 pounds will give you the weight of that per foot. And then here I just multiplied linear per foot. So that's the weight of this in 1 foot. And then here I did this times 492. So this is how many cubic feet it is. It's a very small number, and then you're multiplying it by steel weighs 492 pounds per cubic foot. I could be wrong on that, but it's going to be very close. There's a slight difference in some, but just I shouldn't have probably checked that before I did it, but that's what I recall. And then we have the thermal expansion of steel, specifically steel tapes, is right around 11.5 to 12.2 or something like that. I think I just used 12. Not a huge number, but it needs to be approximately close. And then we have difference in elevation. So those are inputs. Here's your elevation of 0.1, another input for 0.2, and you have the actual temperature. You have the pull in tension, pull in pounds per foot, pull in pounds, 15 pounds, right? And then the measured length here is just an example of 100 feet. So reason why this all happened is because I needed to know what the difference, the sag correction was at 100 feet and the temperature correction. So I did that. And then, so here's the difference in elevation, which is just this one subtracted by that one, right? B11 minus B12. I'm gonna zoom in so you can see this if you're on a smaller screen. And then there's the slope. So we have the diagonal is the measurement that we're taking, right? And then we have the rise, so the rise divided by the diagonal, which is the arc sine, that's the angle. And I should probably, let's do this, format cells. This is in degrees. I'm going to do format number, give me a couple more decimal places, about 5 decimal places. So it says 0, 0, 0, oh, because there's no slope, right? So if you had 100 feet, let's say a number that I know is 25. 25 by 100 is about 14 degrees, right? So if we had 100 and elevation of 0.1, 25, 125, enter. So you give you about 14 degrees, right? Let's see, so it seems like it would be, oh, because it's the cosine, not tangent, so it's a little different. Anyways, that's kind of what we're looking for. So 100, we just put that there for now. This is really kind of what started it, not the slope stuff too, but it's in there. And tape in pounds per foot, there's the number. So if you see this formula with W squared times L squared, W cubed times L squared, it's because they're taking the total weight of the tape, which is right here, 0.768 pounds versus pounds per foot. That's the only difference, right? And then the length is the same. It's either squared or not squared. Here we're using the weight of the tape per foot. So we have, there you go, 0.76. That's the tape in pounds per 100 feet. And then temperature constant, and then tape in pounds per foot is this number. So it's just basically, I kind of went up and went back, but that's the number we're using for this formula. Horizontal length, that's the measurement that we have if this was, let's say that was 125. The horizontal length would be different, right? And it would be 96.8, right? So that's where that comes from. Enter. And let's see, there's a horizontal length, which is cosine of the degrees. That's why I got the degrees. There's probably another way to do it, but I had the sine here and I needed to get the cosine, so the easiest was to bring it back to degrees, arc sine, and then the cosine to find the horizontal distance. All right, so I wonder if I could have gone straight to tangent for that. No, I don't think so, because we're given the 100-foot diagonal. And let's see, tape per foot, and then horizontal length, and that's the formula constant. And there we go, right into sag correction. So I'm going to highlight the sag correction. We're going to go B20. I'm just going over that with you right now. So here's our measured length, right? And in the formula, let's see. So here's our, the sag correction, right, is going to be your dimension minus or plus the, well, actually sag correction, you're always going to deduct, right? So this one, we're putting the minus sign. It's consistently going to be minus. You're never going to have an opposite of the sag, right? So the sag's always going to be subtracted. So if you end up with 100 foot, your measurement with sag's always going to be 100 foot plus, and or any dimension that you take a chain from. So B19 is right there, pounds per foot, that's the W, times how many feet, right? That's the weight for how many feet squared. So it's a little unclear what that is, but that's the weight of the length of your tape total, right? So if I took anyways, that's how it goes, right? So if it was just the weight, I think weight per foot, it would be cubed and then the length squared. I think I said it backwards the other time. We have, there's our length. Oop, I don't want to do that. So times squared times B20, which is the length, B20, 100, divided by 24. There's our constant, B21. There's our constant, which is, actually can't see it here, it's B21 times, and then you put it in parentheses here because you don't want to divide the this and then multiply by that. You have to divide it by this whole group of numbers, which is 24 times p squared. So then p squared is the pole 15, which is the green one here, squared. And that's it. Okay, and then right here we got the thermal expansion at 12 parts per million. So it's 12 times 10 times 10 to the negative 6, which is a millionth, right? Parts per million, 12 parts per million, times B7, which is the thermal expansion, right? 10 to the negative 6, times 12, which gives you 12 parts per million, times, and then B12 minus B18, which is the difference in temperature. So it'd be 69 minus 79, and it's important that you do it in that order, because right here, B12 minus B18 is going to give you a positive number, which means the number is going up above 69, right? So it's a positive number when you subtract those two, and then you're going to multiply that by the measured length, right? So your thermal expansion is 10 to the negative 6 times the constant 12 times the difference in temperature times the length. And that's it. So in this case we have, let's see, if this is 69, also 69, the correction would be 0, right? And so every 10 degrees in temperature at a 100-foot tape, 3/8 100-foot tape, you're going to get about an 1/8 of an inch correction. So if your tape gets long, so this could do a whole nother video anyways. Let's do this. So we have the sag correction here, 99.99. There's that 1/8 of an inch I'm telling you about. So you got to deduct 1/8 of an inch, right? So if you look at this, the sag correction, and without the thermal expansion, the actual measurement that you take for that 100-foot tape is 99.99, right? So it's not 100 feet. With the sag, it's 99.99 or 989. So if you're measuring, let's see if I could explain this one shot. Let me type it, it might be easier. So short tape, which means cold, right? Cold tape, and when you're measuring is you're going to deduct to get the right measurement, right? So let's say you measure, when it's cold, you measure 100 feet, you're actually going to be measuring 99.99 feet, right? If it was 10 degrees difference, because 10 degrees is about an 1/8 of an inch at 100 feet. And I don't know if I wrote that down, but that's what you get. So, but when you're laying out a short tape, you have to add. And it makes a lot of sense. It takes maybe a little bit to wrap your head around there. So, and then the other would be long tape, hot, right? When you're measuring, you're going to add, right? And then in the opposite when you're doing layout. So short, which is cold, when you're laying out, you're going to add. So if you got a short tape, right, and you're going to use it to lay out a 100-foot length, you're actually 100 feet is actually at 99 feet, so you need to add to get to the 100 feet, right? Well, it's an exaggeration, but, and then the same thing here, it's opposite. So long, hot tape, laying out, subtract or deduct. All right, so that's how that goes, in case you didn't know. So if somebody ever asks you with the cold tape, do you add or subtract? It's kind of a loaded question, because you would add if you're doing the layout, and you would subtract if you're measuring. So as built compared to laying out, they're opposite. So let's see. So just typical sag correction for 3/8 tape is 100 feet at full length of a 100-foot tape. The thermal expansion for a 100-foot tape is an 1/8 of an inch at full 100 feet for every 10 degrees of Fahrenheit. And the parabola length for a 100-foot tape distance is 100 foot 1/8 or 100 foot 1/100th for 7.5 inches of sag, which is what I did. I did set up a baseline, shot it with the total station. The sag was 7.5, and I came out with exactly 100 foot 1/8 of an inch. and it was like 70 degrees. And the pull test, I put the pull test on there at 15, and it was an 8th. I think 20, I was at like a 16th. In fact, let's see if we change that to 20, enter, and I think we had with zero tape correction 995. Yeah, it was a 16th of an inch. But it's not worth it, right? If there's no need to go to 20 pounds. It's just it's much harder. If you got a tape puller, then it would be no problem. You could do anything you want, but that's what I came up with, and that's how you run that whole thing. So I kind of went here, you get the tape per foot, just going through telling you what information that you need. You need the thermal expansion, and it's important. The thermal expansion is an 1/8 of an inch per 100 feet for every 10 degrees. So if you have, let's see, actual temperature 79, enter, that's probably going to work out to balance out to exactly 100 feet, right? Because if you're measuring 100 foot and you're raising the temperature, you're going to deduct, and then, or you're going to add, right? So the sag correction, you're going to subtract. The thermal expansion, you're going to add, because you're measuring, right? Hot tape, measuring, you add right here, right? So that's kind of how it works. I hope that helps you understand that you can pull 100-foot tape. The smaller tapes are better. The 3/8 tapes are a little more prone to damage. Shock loading them, they'll stretch, but you don't want to take very good care of your tapes. This is the Stanley FATMAX, kind of a cheap tape, but it works really good, and like them, they reel up really fast. And what else can we say about the tape, this thing here? This is not necessarily necessary, right? You could shoot the elevation, but the diagonal works really good. If you got the elevations, you can put the elevations in there. Pretty much it, man. So I hope that helps you understand the tape measure, sag, and thermal expansion correction, and pull. So those are your 3 factors. Like I said, if it may look like this. See that the correction for sag, actually it might look more like a small s, equals, and it would be W. It would be that, it'd be W squared, or cubed, times L squared divided by, and then the bottom doesn't change, 24 P squared. That's, you might see that, and that's just like I explained. Right here, we're taking the total weight of the tape all across. The other one here, you're taking the weight per foot, multiplying it by the length squared, and then dividing by the same constant, and pull. All right, hope that helps you in your career, and thanks for watching.